Hello and welcome back to another VMK in the Math series. In this VMK I'm going to talk to you about the unit circle. Now the unit circle is used a lot in mathematics whenever we're dealing with trigonometric functions. And usually it comes up when you have to work with points that are located either on an arc or in a circle. So let's get started and go into PaintShop Pro and take a look. What I've drawn here is a circle centered about a coordinate system here, and the coordinate system's origin is located right here at this very center of the circle. So x is going to travel in this direction, and y is going to travel in this direction. So positive y is up, and positive x is to the right. Alright. What we want to do is, and I guess I should mention here that the center point is located 0, 0. Now, what we want to do is figure out what are the values, in other words, the x and y coordinates, of all the points along this circle here. We know that everything to the right of the y-axis here is going to have a positive x. Everything to the left is going to have a negative x value. Same thing goes for the y-coordinate. Above the x we have positive, and below the x we have negative. Now, when we talk about the unit circle, what does that really mean? Well, the unit circle refers to a circle that is drawn that has a radius of 1. So let me just draw in here. Imagine this being a straight line and this being the radius. And we're going to make this equal to 1. Whenever you have this condition, then we're talking about a circle that's a unit circle. What we need to do is go back to our trig functions to figure out what are these points here along the curve. There are a couple of trigonometric functions that you should be aware of, so I'm just going to write down the important ones here. We have sine theta, we have cos theta, and we have tangent of theta. Now we're not going to be talking about tan theta in detail, but sine theta is basically defined as y over r. Cos theta is defined as x over r. And tangent of theta is defined as y over x. Now this is only true if you have a right-angled triangle. And the right-angled triangle here, let me draw it this way. So here we have a 90-degree angle, and our theta is defined as this angle here from horizontal upward. And the distance from this point down to the end is x, and the distance from down here up to the top is y. And the distance from the end down the end of the hypotenuse, that's r. So if we have this triangle, then the sine of the theta is equal to y over r, so it's this distance divided by this distance. Cos theta is equal to x divided by r, and tangent theta is equal to y divided by x. Alright, so given this information, we can then transpose that information onto here to figure out what are all the values. Well, let's take a look. We can take sine theta and rewrite this a different way. Let me do that over here. If we write r times sine theta, this is equal to y. So in other words, what we did is we took this r value and multiplied it by both sides. We can do the same thing with cos theta. If we do that, we get r times cos theta is equal to x. Well, now we have a relationship between x and this thing here. And for a unit circle, we have r equal to 1, which basically simplifies that x is equal to cos theta and y is equal to sine theta. So, knowing this, any point along this curve is just equal to cos theta, comma, sine theta. Doesn't matter where the point is. Could be over here, could be over here, doesn't matter. The only important thing to know is what is theta, because theta defines the arc that is formed from the horizontal. So we're going to start here. Imagine this line is perfectly horizontal, and we're going to work our way upward. And notice the way that I'm drawing this. It's counterclockwise. So that distance, or that angle, is represented by theta. Once we know that angle, we can then go and calculate precisely what is this point in two-dimensional space. So in terms of the x value and in terms of the y value. When working with the unit circle, there is another thing that you have to be aware of. The theta that we use here always should be represented in radians. Now, when you plug in numbers inside of a calculator, by default your calculator is set up to work in degrees. However, when you do the calculations in a computer program or other kinds of programs that use sine and cos, most of the time they're defaulted to work in radians. So you need to know how to convert from radians to degrees and from degrees to radians. This is kind of helpful. Now, in a unit circle, as I said earlier, theta is drawn with respect to this line here. So this line here represents theta is equal to 0 degrees as well as 0 radians. If we move 90 degrees, so we're now perfectly vertical here, this represents 90 degrees, but it also represents pi over 2 radians. If we travel half of the distance around the full circle, so we're now over here. Oh, that's a pretty bad line. Let me try to redraw that again. If we are over here, then we're located an angle of 180 degrees or pi radians. Both of these are equivalent. And the last one that's pretty important to know is this one here. If we travel all the way like this, then we have 270 degrees, or the equivalent is 3 pi over 2 radians. Now the points along this curve you can calculate quite easily, or you can actually just look on the unit circle sometimes to figure out what they should be. So let's take an example. Let's say we wanted to know what is the coordinates of this point here. Well, just by looking at the unit circle, we can see in the x direction, we don't travel anywhere, so we're at the origin, we go straight up, which means the x value here has to be 0. The y value is exactly at the edge of the unit circle, and we know by definition a unit circle is of radius 1. So therefore, this coordinate must be 0, 1. We can confirm this by using the rule here for the x and the y. Cos of theta, where theta is equal to 90 degrees, is 0. Sine of theta, where theta is 90 degrees, is 1. So once again, we get 0, 1 as our two coordinates. If we wanted to know this coordinate here, well, just by looking at the unit circle, we can see it's -1 units in the x direction and 0 units in the y direction. This point down here is 0 units in the x direction and -1 units in the y direction. And this one here for theta equals 0 degrees is 1 and 0, because we traveled 1 in the x and 0 in the y. There are 3 other common values that are sometimes used, and those are the values at 45 degrees, 30 degrees, and 60 degrees. These numbers are kind of common because the math that works out here kind of gives you nice looking numbers, and they're relatively easy to remember as well. For 45 degrees, that would be a line that's drawn exactly halfway between 0 and 90 degrees. What you get there for this point is 1 over root 2, comma, 1 over root 2. For 30 degrees, that would be a line sort of like so. Then that coordinate works out to be root 3 over 2 and a half. And for 60 degrees, that's a line that's a little bit higher than 45, something like this, and that one works out to be a half and root 3 over 2. So these are some numbers you can go ahead and memorize. They are very useful whenever you're working with unit circles or anything that's sort of along an arc. But again, you don't have to memorize these, because if you know this formula, x equals cos theta and y equals sine theta, you can then go and basically figure these values out by using a calculator.